Do you know we can determine tension, compression, or zero force members in trusses without any calculations? This is termed as qualitative structural analysis. Qualitative analysis is extremely important when it comes to initial designs. It gives engineers initial idea of how the structure is going to behave. In this tutorial, I will cover IStructE certificate course on structural behavior, and I will solve two trusses in here. This is the first example which I will solve today. Members in this truss are subjected to compression, tension, or zero force members. Remember that diagonals here only take tension, and that makes this problem really very tricky. And I was myself caught up in this question, and I got this wrong while I was practicing the questions. So bear with me, but I will tell you very useful tips how to tackle these kind of questions. And there are four options: option A, B, C, and D. And they are very close to each other, and it's very difficult to determine which option is correct. If you want to try this question first, pause this video for a few minutes and try to see which option is correct. That will really give you a very good experience of learning, and then you can see the explanation. Click on this URL to take the quiz, or scan this barcode to take quiz, or take a screenshot of the options and solve it yourself first. And the links will be down below in description as well. Now let us evaluate these options. But before I evaluate the options, there are certain golden rules that need to be followed, which I've covered in my very first tutorial on trusses. Click the link over here to have a look at that tutorial in detail, but I will cover it here very quickly. The first rule is that two non-linear members, when they meet at a joint, they are zero force members, and the angle between them has to be less than 180 degree. Here, these are non-collinear members meeting at certain point, so these forces are going to be zero. This is rule number one. The second rule is when there are two collinear members and a third member is being attached to that third member has to be zero. So in this truss, observe that which members are zero. You can see that pretty much everything has disappeared, all right? And rule number three is that collinear members will have same forces. So for example, left side is compression, right side has to be compression as well. If left side is tension, right side is tension. If it is zero, the right side has to be zero. So these are three golden rules. Remember these rules. We will use these rules to apply to these options. Now the first option that I would like to have a look is option A. In option A, you can see this truss is fixed at one end and it is free at the other end. So what will happen when you fix something on one hand and it is free at the other end, loading is applied over here? What do you think? Top will be in tension or compression? Normally top is in compression and bottom is in tension in simply supported structures. But here it is fixed at one end and free at the other end. Load is applied like this. So when you are applying loading like this, the top is always going to be in tension and bottom is always going to be in compression. I will prove it in a minute. How does it work? And remember here that diagonals only take tension. They don't take compression. So first we have to determine that which diagonals will take tension and which diagonals will take compression. So here, firstly, I will have a reaction over here. So first I have a reaction here. I don't know what is the direction of horizontal reaction, but vertical reaction will be like this. If I have a reaction like this, then vertical component of this member, that will point towards the joint. So it will be like this. So vertical component has to go downwards, which means that it is pointing towards the joint. When members are pointing towards the joint, then it is compression. Away from the joint, it is tension. So here, this member is being subjected to compression. When this member is being subjected to compression, then simply I can say that it's a zero force member, because these diagonals, they cannot take compression. So by symmetry, I can say that this member will take compression, this member will take compression, this member will take compression as well, and then I will rub them off. So let us rub them off. So these all members are taking zero force. Once zero forces are determined, now have a look at this joint. It follows the first rule that when two non-collinear members are being attached, the forces in them will be zero. And again, if you have a look at bottom, when this is zero, then I will rub off these top members and let us see what happens. So when these two members are rubbed off, then you will see that at the bottom we only have two members here. It means that the force in these members will be zero as well, because it follows first rule, two non-collinear members meeting at a point at unloaded joint, they will be zero. Let's go and rub this off as well. This is a vertical load being applied here, and vertical load means that it is going to cause compression here. It is downwards, and here it should point upwards. Pointing upwards means it is a compression. And for this horizontal member, there is no other horizontal load applied. So the force for horizontal equilibrium is going to be zero in this member. So that's why I will have a zero force over here. In option C, you will see that we have tension over here. Tension is not possible for horizontal equilibrium. It means that option C is incorrect, and option B is incorrect as well, because you can't have this compression over here. These are zero force members. This option B is incorrect as well. Option D is incorrect as well, because there is tension over here and tension is not possible. So the correct option is option A, and you can determine these other forces as well. So our correct option is option A. These members, these diagonals, they are taking tension, because if you imagine, if you are applying loading over here, the diagonals which are attached like this, they will experience tension. So that's why we have tension in all of these. We will have compression in verticals because vertical load is applied, and we will have tension at the top and compression because it's a fixed beam. In fixed beam, we'll always have tension at top and compression at bottom. So that's the reason option A is correct. You saw that how tricky this question was. Just a small thing can change the questions, and answers are very close to each other, and they are there to obviously trick you. The correct answer is option A. Did you get it right? If you didn't get it right, it's all right. You can see the explanation and take the quiz and then learn from it. That's how we learn from each other. I will now go to the next question. In these questions, the members will experience tension, compression, or zero force. We have to choose the correct option. If you want to have a go at this question, pause this video for a few minutes and attempt this question. I will show you the options as well. Take a screenshot and attempt this question on a notepad or a notebook. These are the options that we have. Option A, C, B, and D. And I extremely forgot that what option was correct, so I did not practice it. Let us see how it goes. So let us evaluate these options first. If you want to take this quiz before watching this video, scan this barcode and take the quiz, or go to this URL and take the quiz. The links are down below in description as well. So let us go through this question. Now first I will apply first rule, which was that two non-collinear member meeting at unloaded joint will be zero. Here you can see option A, we have unloaded joint, so that's the reason we have zero force here, zero force here. It means these two members, they will disappear, and that leaves this joint as unloaded as well. Now there are two members attached and they are unloaded. That means that this member will have a zero force and this member will have a zero force as well. Now this side of the things has completely disappeared. In fact, I can rub this off. Now I reach to this joint over here. With this joint, I have again two members connected. So these two members will be zero force here and zero force here. And finally, I come to this joint here. This is again connected with two members. There will be zero force here and zero force here as well. And now I move to the top joint. This joint, we are applying load downwards, so there would be compression over here, but you have to see at joint at the top as well and see what is happening there. Now this joint is, again, all of these joints up to this point, they have zero force members. Now I'm at this joint where you can see only two members are connected and those two members are the joint is unloaded, so that's why this member is going to be zero, this member is going to be zero as well. For this joint, we have a downward force. The vertical component of this member, it should point upwards and horizontal component should point leftwards. So which means that arrows are pointing away from the joint for this member. When arrows are pointing away from the joint, this is termed as tension. So it means that this tension is fine. Now let's go to option B. In option B, this is incorrect because you can see we have tension at the bottom and we have compression over here, which is not possible, and we have tension over here as well. So option B is incorrect. Option C is incorrect because we have C over here and we have compression over here, which is not possible as I showed you. That's why this option is incorrect. Option D is incorrect as well because we have tension here, and that's the reason this option goes away. Our correct option is option A. So we have determined tension over here. Now only thing else is how do we determine forces here. So the horizontal component for this member is pointing towards left. It means that the horizontal component of this member should point towards the joint. When it is pointing towards the joint, then it is compression. The answer is clearly option A, but I'm explaining how can we determine these tension and compression forces. So compression is fine. If we have a downward force, then the reaction has to be vertical over here. When we have upward reaction, then force here should be downward in this. So force will be downwards and leftwards, which means that the force here in this member, inclined member, is going to be compression. Because of this horizontal component leftwards, the reaction here will be rightwards. When reaction here is rightwards, then reaction at this point at other support should be leftwards. When the reaction at top support is leftwards, then the member force here should be pointing away from the joint. When it is pointing away from the joint, it is termed as tension. Now you saw how did we solve this question and came to the right answer. So correct answer is option A. If you want to see entire video series on structural behavior, and if you wanted to take IStructE Structural Behaviour Certificate course, just scan this barcode or go to this URL. Links will be down in description as well. Or if you want to improve your general understanding of structural engineering, then it's very useful video series. Just simply have a look. And you can download the copy of lecture slides by going to this URL. Link will be down in description as well. And by going to this barcode. Thanks for watching this lecture today. I will see you in my next presentation. Thank you.